I want to turn our attention now to an algebraic version of the money market equilibrium as we depict it in the LM curve. So we've seen a graphical version of that. I want to have a bit more explicit version using an equation which makes the relationships, the behavioral relationships, if you will, more explicit. So recall that the LM curve is where money supply equal to money demand. So money supply, the real money supply is the money stock divided by the price levels. That's the real value of the money in circulation. And money demand traditionally is depicted by L. So this is, the money demand is a function of both interest rates and national income. People change how much cash they want to hold in their hands based on the number of transactions that they want to undertake. That's related to Y. And R is the opportunity cost of holding cash instead of getting funds from a bond, where you would earn the real interest rate, or in holding in other types of interest-bearing assets. Okay, so what I've got here is an explicit version of money demand where I've got a couple of different variables where Ly is the sensitivity of money demand to interest rates. I'm sorry, to national income. That measures how much consumers might want to change their money holdings depending on how much income there is. And LR is the analog for interest rates. So this money demand function has the simple linear version is the level of income multiplied times the sensitivity minus R times the sensitivity to of money demand to interest rates. And if we say that that is in equilibrium, where money supply equal to money demand, we can then use this expression to get an explicit version of the LM curve, where we've got R on the vertical axis and national income on the horizontal axis. So what we want to do is just simply isolate R. So what I do is I'm going to pull R over to this side, and I'm going to pull the money supply over to the left-hand side. So I've just switched places. And now I'm going to divide both sides by LR in order to isolate R. Okay, so what have I got? 1 over LR, and then LR. And so what we have here is a linear equation which will have the following relationships. This is the intercept. It's not a function of Y. It would be somewhere down here. So this is the money supply multiplied times 1 over LR. This is the slope of the LM curve, which has a slope of Ly over LR. Okay? Now, one of the advantages of this explicit form of the LM curve is that it allows us to see very clearly how the money supply would change the LM curve. In this version, a bigger money supply that might be created, for example, by an open market purchase of bonds by the Federal Reserve would shift the LM curve out because you would have a larger negative intercept. Shifts the LM curve out very explicitly. This also tells us how the LM curve might change depending on how sensitive money demand is to changes in the underlying behavior. For example, let's imagine that money demand was more sensitive to changes in national income. Now you have to think that through hard in a graphical version. Now you have an explicit version. A larger value of Ly makes the LM curve so Ly being bigger makes the LM curve steeper. That means for every level of national income, say right here, there will be a higher interest rate that will cause money demand equal to money supply. Essentially, the higher LR, for a given income, you're going to have more money demand, in which case the interest rate will have to be higher in order to tamp down that level of money demand. So we had a version kind of similar to this with the IS curve, much more complicated because we had various components. We had consumption, investment, government spending, lots of things going on. Money demand is actually a little bit simpler, at least in terms of the algebra. So we will see that in a separate video how changes in the underlying assumptions about these various components will shift the LM curve, change the shape of the LM curve in a very explicit way. So let me just finally do the last version. What if instead the sensitivity of money demand changed in relationship to interest rates? Well, this is going to affect two components. Okay? For one thing, a larger sensitivity here for the same level of money supply, this will be a smaller, okay, this part will be bigger. That means that this whole intercept will be smaller, so it's a smaller negative number. And a larger or a higher, more sensitive money demand to interest rates means that slope will be smaller. So the LM curve would shift. So what you have is another example of, for a given level of national income, the more sensitive money demand is to interest rates, the lower the interest rates would need to be, okay, in order to have money demand equal to money supply. Okay, so that's a quick overview of how an algebraic version of the LM curve is derived and how one might manipulate it. If you're given specific numbers, you'd be able to use this relationship to come up with explicit demand for money and the equilibrium level of interest rates and national income. And this gives you a more explicit version of the money market equilibrium that's embodied in a graphical version.